Use the definition dy dx equals this limit. This is the definition of the derivative, isn't it? To differentiate the following. Y equals fx equals 4. So dy dx then will equal the limit as h tends to 0. Now f of x is always going to be 4, so it doesn't matter what value you put in, it's a constant value of 4. So it's a limit of 4 minus 4 over h, which is the limit as h tends to 0 of 0 over h. This value, for h tending to 0, so you don't have to take in the value at 0, but just as it tends to 0, 0 over something is 0, as h tends to 0, and that's equal to 0. So there's the first one. And we said constants, which is this one is, differentiates to 0, didn't we? So that agrees with our table. Here, dy dx then, let's write it down here, is equal to the limit as h tends to 0 of, now, remember what it was? fx plus h on the top. So 3, if you put x plus h in here, wherever you see an x, you input the x plus h value. So 3 of the something minus 1 is the fx plus h. That's that, minus fx minus the f of x, which is 3x minus 1, more than one term, put a bracket, over h. So what do we get here? It's the limit as h tends to 0. Expand the bracket, 3x plus 3h minus 1 minus 3x, and then minus runs through here to be plus 1 over h. Limit, the 3x's cancel, the minus 1 and plus 1, we're just left with 3h over h, which is 3 as h tends to 0, which is just 3. And if you look at this, when you differentiate this, you could just, using the rules of differentiation, see that would differentiate to 3. Next one. So have a look at this one then. So dy dx is equal to the limit as h tends to 0 of fx plus h. F of something is 2 times something squared minus 7. The something is x plus h minus fx, which is 2x squared minus 7, more than one term, put a bracket, over h. So remember what we did? fx plus h, something is x plus h. Here's the rule, f of something goes to 2 times something squared minus 7, 2 times something squared minus 7, minus 2 times the something, which is x squared minus 7. Over h, let's see what we get. Lim 2, and this bracket is x squared, plus 2xh plus h squared, isn't it? Minus 7, run through the minus, minus 2x squared, minus minus is plus 7, all over h, as h tends to 0, which is limit 2x squared plus 4xh plus 2h squared minus 7 minus 2x squared plus 7. So I've just times these 3 terms by 2 and written down these 3 as well. Okay, the 2x squareds cancel, the 7s will cancel. There's an h common on top. So this is equal to then lim, take the h outside a bracket, 4x plus 2h over h, as h tends to 0. So the h's cancel here and here. We get 4x plus 2h. H tends to 0, this tends to 0, and just leaves the 4x. Which hopefully is what this differentiates to. Yeah, 4x to the 1, and the constant goes to 0. Next one. So it's now lim fx plus h, which is 1 over something, x plus h, minus 1 over, minus the f of x over h. Bit of fraction work here. Cross multiply x minus x plus h, got the bracket around it, over, and then the two things come underneath, don't they? X plus h times h. And that's the limit as h tends to 0. That's equal to h tends to 0. Run through the minus, you get minus x, so they'll cancel, and you'll just get a minus h on top over x plus h times h, which equals the limit. These will cancel. You'll have minus 1. And here, I'm going to expand this bracket now. You'll get x squared plus hx, or xh is the same thing. H tends to 0, this will tend to 0, and we'll get minus 1 over x squared. Which we know this differentiates to if this is x to the minus 1. So it differentiates to minus 1 over x squared.